Hi guys, this is Gaz from Punk, and I thought I would talk a little bit today about crunch compression in Unity. Now you may have seen a message say, for example, on this one here, that it says when you go to compress, it says only pot texture can be compressed if bitmaps are enabled. Only textures with width height being a multiple of 4 can be compressed to crunch format. So it's annoying that you can't get the full benefit of crunch. So I decided to convert them to pot, which means power of 2, right? They can be divided by 2 and there's no remainder. So to see what the benefit would be, I did it. So difficult actually to work out how to do that, what the next power of 2 is. For example, here's the image that I'm wanting to compress, right? And you can see in my build, it takes 212 megabytes just for this image. And its size is very large actually, 14,288 by 8,907. So I wrote a little Java program to get the next power of 2. So if you enter 14,288 into there and you run it, the next power of 2 comes up as 16,384. So this is what you do. Put that in there. Sorry, you want to use the canvas size, right? You go to canvas size, change that to pixels. Don't click relative. So if you put in 6,384 and you click OK, you can see that the canvas gets a lot wider, and it's on its way to being able to be power of 2. But obviously we need the other, the width, the height too. So if you take the height there, 8,907, and you put that through the program, surprisingly it comes out at the same 16,384. So now you put that into the canvas size and you press OK. You can see now canvas is much taller, basically square. So you'd assume, well, that's going to use too much memory and stuff, but it does actually compress a lot better. Another trick is if you do have a layer that is off that you don't really need, like this, you can actually delete that too, because that is still being stored in the file and taking up size in Unity. So we can see here, right, the original file is 212 megabytes, yes? Let me make a note of that, because I've been doing lots of things and you forget these things. So, if I, first of all, I'm just going to delete the one that we don't need, right? So that'll reduce the file size already. And now that it is power of 2, I'm going to save it as the same file name, but with underscore pot for crunch. And I've already done this, so I'm not going to do it again. But you can see that actually, just by removing the redundant layer, it's dropped over 232 megabytes on the disk there. So what happens if you build it in Unity? So what I'm going to do here is come in here. Now you can see I've got this file called, this game object called Vela Fake 2D, and that's because these levels used to be full 3D, but I realized actually I could achieve exactly the same with 2D because it's an orthographic camera and it doesn't really matter. So what I'm going to do is duplicate that. Now the best bit about this is you think, oh, making the canvas larger will be annoying because you'll have to position the image, but actually you don't. If I just drag Favela Pot for Crunch onto the sprite renderer, which is on the right here, you will see that actually it fits perfectly in the same position. So I drop it on there, literally nothing changes. Oh, pot for crunch. Yep. Nothing changes at all. if I turn that one off, I can prove that. Same. Now you'll actually see that my pot for crunch is a bit clearer. That's actually because I've got it on a higher import. So let's put it back to the same import settings as the other one for this test. Now, when I build this, you will see the difference between using a power of 2 image and a non-power of 2 image. So yes, it's 212, right? I'm going to pause this and build just so you can see how much better it is with crunch compression. So I've got crunch compression turned on that one. I've got compressor quality 100% there. I might as well put that one up just so it's a fair test. So I'll build now and I'll get back to you in a second. Okay, that has built, and now look at the size of the pot one, power of 2 compressed, 64 megabytes. Even though it's a much bigger image, just because of the crunch compression, which looks identical by the way when you use high quality, it's 64 meg versus 212 meg, which is huge. I was looking at ways to compress this game further because it's actually for the Nintendo Switch, and you need to make these things small and that for the Switch, and just all games really could benefit from being made a lot smaller. So if you take any massive image that is really taking up too much space and you crunch compress it by making it power of 2, the size is drastically smaller. What's that, like? I don't know how much smaller that is. We'll work that out right now, eh? So 213, we'll say, divide by 64.1. Yeah, that's 3.3 times smaller. And nothing has had to change. So I want to do the same for the other images now. So I'll start with submarine. That one's 315 megabytes, which is, insane. These images, by the way, are very large, as we saw the resolution, right? This one is actually not as big as the other one, just because the level itself isn't. And you can also see here a redundant layer that is locked. So if I check the file size, which is let me pause it while I find that. Yeah, the file size is 239 megabyte for submarine on disk. So if I just delete that redundant layer, which I haven't done before, I normally just leave them in because I assumed Unity would turn off, strip out things that weren't visible, but obviously not, because it needs to possibly turn them on via code. I've never done that. We will see that the file goes down to 160 already, which is ridiculous. Now we try the same power of 2 trick. So we go canvas size, pixels, take that number, put it into my Java program, run it. Yeah, it seems to always come out at 16,384, which is, I don't know, I didn't expect that for some reason. We'll do it in the next one. It'll be the same answer, no doubt, but just to make sure. Yeah. So now the canvas will get huge, but it's power of 2, which means it will be compressed. So I'll save it now. And then in Unity, turn on crunch compression. See, it had it on, but it's... Oh, that one could compress, so that's not a very good example. Surely. It wasn't the power of 2, though, was it? Oh, it is because I've just fixed it. That's why it's power of 2. Okay, let's apply. And also, I don't think this uses any more RAM, as you may suspect. Well, it's a huge image; it must use more RAM. It doesn't seem to use more RAM. Maybe transparent pixels are dropped. I don't know. Of course, also if you don't need bitmaps, you can turn that off, and you get an even bigger saving. So, should we do that? Yeah, do that. So as you can see, right, in the build it was 315 meg. I'm going to note that one down. And then I'm going to pause this, build it, and we'll check how big it is afterwards. Okay, there it is. By removing the redundant layer and using the power of 2 and crunch compression, it is also down to 64 meg. So that must be literally because of the 16,000 by 16,000. They're always going to take the same size, but 315 megabytes down to 64 megabytes is comical level of saving, which means crunch compression is amazing, and there's no drawback or hassle to do it unless it uses more RAM. But this is for the Nintendo Switch, and even that hasn't run out of memory, so must be working pretty good. So I'm going to do the same with that one, tenement level top. So we go into Unity. Now this tool, by the way, build report. This is build report tool from the Asset Store. I recommend this for everybody to fine tune the size of things. It's absolutely brilliant. You can actually go here to used assets, order them. You can see, oh, I just want to look at textures. You can order them by size. It tells you the size before the build, size in the build, and the percentage it's taking up. This one we're about to process actually takes up 21%, 22% of the entire game, which is ludicrous. So let's fix that. You can ping them in your project too, which is really awesome because it will bring you right to them. So yeah, I'm going to note that one down again. Just I forget these things. 298 meg. Fire that up in Photoshop. Again, you can see a completely redundant layer there, which I shouldn't have left in. I'm going to go through and do this with all of my games, to be honest. Now I know about this. Power of 2 and redundant layers. We'll delete that layer, and we go to Image, Canvas, Pixels. Now I'm going to put this through my program again. I find it hard to believe, to be honest, that these answers are correct. Why is it? Why will it need to be 16,000? Oh no, there you go. Okay, that one is lower, 8192. So I predict that actually this will use 32 megabytes of storage space if they're both. No, that height one's going to be a problem, isn't it? Because it's going to push it up. Let's see. Yeah, that one's 16,000. It's annoying, actually. If you could get it just within the other one, you get an even better saving. Which I probably could do, to be honest. Cut off 600 pixels. No, I'll leave it for now. So now you go, okay. You can see the canvas is really tall. Again, when I drop this into the game, there should be no problem. So I'm going to save it. I'm going to go back to Unity. Now I'm able to crunch compress it, stick it up to 100. It does make a difference, it's blurry on 0. Put that on high quality because it looks better. It might take longer to load actually, but we apply that. Now I'm going to build it again. I suspect it'll be between 32 and 64, but we'll find out, won't we? Okay, build report is generating, and it was the top one, 42.7 megabytes, as I said, between 32 and 64. So that's from 298 megabytes down to 42.7. And if you designed your images to fit within the 8,000, whatever it was, by 8,000, then you would get even smaller. That would have been 32, I think. Just to labour the point, I'm going to do it with the bottom one, which is quite small right now. Bottom one is 56.5 meg. So we find it in the project. Go to image, canvas size, pixels. This is a very wide one. I'm worried that it's actually hyper wide. It won't fit within that 16,000. No, it does. Perfect. So the closer you can get it to fit, the better it is. And I guess this 2,000 one will end up at 4,000 or something like that. I know this get power of 2 method might be wrong. I could actually maybe improve that, but I don't think so actually. Yeah, 4,096, and I nicked that from Stack Overflow, I think. Right. As you can see on this one, the canvas just gets a little bit bigger. Save that. Go back to Unity. Now it'll be allowed to be compressed. You can put that up to 100. High quality. Also note that filter mode trilinear is much better on these big images, much less blurry, so I will be applying that in a minute once I've done this. So if I apply that now and then build, we'll see it gets smaller. Okay, it's packaging. Shall we predict how big it'll be? It'll be less than 32, won't it? Between 24 and 32? I'm not sure. We'll find out. Okay. That one became 21 megabytes from 56. That's still nice. Very nice. And these are the settings I'm using for all of them. Resize algorithm Mitchell looks better than bilinear. Filter mode trilinear looks much better than bilinear. High quality compression, use compression 100%. And at the beginning, my build was about, 900 meg or something? I'm going to build once more and just see how big it is. Oh, of course I need to turn on compression and things like that. Before I had default compression type LZ4, which you might not have because this is for the Switch, like I said. And there is actually an even better one. I'll try that, LZ4HC, although that won't be a fair test, will it? So let's build once more. And you can see the size is 1.2 gigs there because I didn't have compression on. Okay, so compression was on, it built. The old build, I've got noted here, was 907 meg. 515 megabytes. That's like gone from a gigabyte to half a gigabyte. Insane. So yeah, tips are remove the unnecessary layers, make them power of 2, turn on crunch compression, and you could actually make it smaller probably with lower crunch and all that, but I don't want things to be blurry. Let's have a look if there's any more savings we can do. Although they're the only comical, colossal images. Instead of taking up like 20%, that one still takes up 9%. the splash screen will be reduced. We'll leave it for now because they are the main ones, right? And you can see the format has been set as DXT5, which is nice. Now I'm just going to verify and prove that none of this should affect anything. So I go back to map 0, if I could type, load that up, and this is the original level Tenement. This is for my up and coming game called Tenement, by the way. Now you can see when you zoom in, the quality, well, it's a little bit blurry. Let's swap it. Oh, what am I talking about? It's already been swapped, hasn't it? Because I saved over the top. Earlier I didn't. Okay, so they're all in. Okay. Well then, I guess that is the end of the video. You can save 50% of your build size by ironically making the images bigger just to compress them back down again. Thanks for watching, guys. Hopefully you do your Power of 2 stuff, and I'll copy this code here into the description of this video so you can use it and get some awesome size savings. Thanks a lot for watching. Subscribe, etc., etc.